Let's go over Chapter 12, the final chapter, Managing System Support and Security. The chapter objectives. Explain the system support and security phase. Describe user support activities, including user training and service desks. That's important. Define the 4 types of maintenance. Explain various techniques for managing systems maintenance and support. Describe techniques for measuring, managing, and planning system performance. Explain risk management concepts. Assess system security at 6 levels: physical security, network security, application security, file security, user security, and procedural security. Describe backup and disaster recovery. List factors indicating that a system has reached its end of useful life. Assess future challenges and opportunities for IT professionals. Develop a strategic plan for career advancements and strong IT credentials. Now let's look at the overview. When the system support and security phase begins, the system is operational and continues until the system ceases to be operational. After delivering the system, After delivering the system, the IT team focuses on support and maintenance tasks. Upon the initial delivery of the system, especially when it's a direct cutover, you can expect there to be problems and users to have questions and concerns on the first day. It would be almost impossible for this not to happen. So whenever there's a go live or an implementation, it's important for all the IT staff to be on hand and focused and to begin creating their knowledge base information at that point. User training. New employees must be trained on the company's information system. IT department may develop a user training package. Training users about system changes is similar to initial training. The objective is to show users how the system can help them perform their jobs. Many IT departments have their own separate training and their own separate documentation department that will handle this sort of thing. Now let's focus on service desks or help desk. And as you all know, or should know, Alberta's has its own help desk. It's the 0205 number. Its job is to enhance productivity and improve utilization of a company's information resources. The help desk is the central point of contact for all IT maintenance activities. So when you call in and you have a problem with the system, it doesn't matter what system or what kind of computer problem you're having. You call the help desk and they can direct the call to where it needs to go and get it entered into the system properly. So the 3 main objectives are to show people how to use the system resources more effectively, providing first level support, provide answers to technical or operational questions, make users more productive by teaching them how to meet their own informational needs. So that's their ultimate goal. A lot of times, if something falls outside this scope, the service desk or help desk will pass the information on. So here are some examples of the roles that service desks follow. So that includes showing a user how to create a query or report, resolving network access or password problems, demonstrating an advanced feature of the system, helping a user to recover damaged data or bad data. They can offer tips for better operation. They can explain an undocumented feature. It can also show a user how to use web conferencing, how to access the company's intranet, and a lot of very general stuff, a lot of software update type information and general information. So the service desk or the help desk, think of it as the initial contact point for the IT department. And it's extremely busy and extremely useful on a project implementation. But continuing on, they also provide information about system specs and the cost of new hardware or software. A lot of times a department may wish to buy new hardware or software for their computers in the department. Financial aid comes to mind here. Lots of financial aid changes. They can recommend a system solution that integrates data from different locations to solve business problems. They can provide hardware support by installing or reconfiguring devices such as scanners, printers, network cards, what have you. They can show users how to maintain data consistency, and using remote desktop tools, they can troubleshoot software issues. And a lot of times nowadays, as you probably know, the offshoring of call centers is huge. They did that at my last position when I worked at Aleutian. Critical factors might include phone or wait times, support staff performance, and online support tools. So let's take a look at figure 12.4. It shows the total cost of operating an information system, including operational and maintenance costs. So let's take a look at some examples of our maintenance tasks. And these are the 4 different types of maintenance tasks that we mentioned. There's corrective maintenance. This is going to be to fix logic errors and diagnose them, replace defective cabling, correct or restore configuration settings, debug program code, perform some driver updates, utilize remote control software for problem diagnosis and resolution, and what have you. Corrective maintenance is going to occur early in the implementation of a new system because it's going to be new and there's going to be unforeseen issues that need to be corrected quickly. As time goes on, corrective maintenance will tend to decrease. Then there's adaptive maintenance. This is really adding new features to the system, new major features that have a different look and feel. Sometimes they can support new features that never might have existed before. That's known as adaptive maintenance. Some examples: adding online capability, adding support for mobile devices, adding a new data entry field to an input screen, installing links on a website, and maybe creating a portal of some kind. Perfective maintenance involves things like upgrading or replacing outdated hardware, writing macros or scripts to handle repetitive tasks. I would think you'd use scripts more than macros. Compress system files, optimize desktop user settings, upgrade wireless capabilities, install newer and better servers. So this is the kind of thing that makes the system better and more powerful as time goes on. Preventative maintenance is always going to be there. This is actually the real, when you think of maintenance, this is really the maintenance that we need to keep up with on a system. That includes developing backup schedules and handling backups, installing and updating antivirus software, analyzing problem reports for patterns, checking cabling. That's something that I can't say enough for. Cabling over time, gravity does take over and pull those cables loose. It can take a really long time, but that does happen. And a lot of times rack-mounted servers are not professionally cabled in the back, and it does take a skill set to do that. Develop a user guide covering confidentiality rules and unauthorized use of company resources. I think I would make that one more of an adaptive or more of a perfective maintenance than preventative, but that's something that's also mentioned there. So here we've kind of gone through the different situations. We've mentioned that it diagnoses and corrects errors in an operational system, responds to errors in various ways depending on the nature. So the worst case scenario is a system failure. A lot of times bad piece of code will fill up a file system, or it'll corrupt the data so badly that it can't be used. The first thing in corrective maintenance is to keep the system up and going, but you always want to diagnose the reasons behind the issues. So here's kind of what I mentioned. Immediately after implementation, corrective maintenance is high, and then it becomes low, and then once the product reaches its end of life, it's high. Adaptive, immediately after, it is the adaptive, the implementation is the adaptive piece, so that would be a none. And a lot of this should make pretty good sense, so I'm just going to stop here and let you guys all take a look at this for yourselves. So here are some different examples of adaptive maintenance. You have the need to add enhancements to an operational system and make the system easier to use. The procedure for minor adaptive maintenance is similar to routine corrective maintenance, and it can be more difficult than new system development because the enhancements must work within the constraints of an existing system. So in this example here, we see a 3-level ranking of what IT support might consider potential impact in its responses. So go ahead and take a look at that for a second. Now, perfective maintenance. It involves changing an operational system to make it more effective and efficient and reliable and maintainable. It's got to be cost effective during the middle of the system's operational life, because that's when it's going to get the most use. Programs that need a large number of maintenance changes are usually good candidates for re-engineering. The more a program changes, the more likely it is to become inefficient and difficult to maintain. It's too many developers spoil the program the same way too many cooks spoil the broth. Continuing on with preventative maintenance, it requires analysis of areas where trouble is likely to occur. The IT department normally initiates preventative maintenance. I believe it's every third Wednesday at Albertus. If you get notice, the systems will always be out then. Often results in an increased user satisfaction, decreased downtime, and reduced TCO, or total cost of ownership. Sometimes does not receive the high priority that it deserves. At Albertus, they're very good about keeping up with patches and what have you. Let's take a look now at the maintenance team. You got the system administrator. They manage the computer user accounts, network systems, system permissions, and security. You've got the systems analysts. That's mostly what we've been talking about and what we are for. Those are the hats that we're wearing for this class, I should say. The systems analysts investigate and rapidly locate the source of a problem by using analysis and synthesis skills. Programmers, whether they be application programmers working on a specific vendor product or application, system programmers who write scripts and utilities to keep the system running along and keep things like disk space free and what have you, they're important as part of the maintenance team, and they fall under programmers, as does database programmers and DBAs. So there's an organization called Cengage. They seek to establish a code of ethics for system administrators to follow. This is because system administrators pretty much have access to everything and anything and everything, since they usually have the highest levels of access. Here is the typical workflow for a maintenance request. Now, of course, every company is different, but this is the idea of how it's going to look. So a maintenance request involves a series of steps. The work must be covered by a specific request. It takes an initial determination. Oftentimes there's a system review committee, and then the task is completed and users are notified. The initial determination piece, this is where the system administrator makes the initial determination as to whether or not it's justifiable. So we can see that right here in this decision tree right there. The system review committee will either approve the request or assign priority to it or reject it. Here's that step right there. Task completion. The system administrator usually assigns tasks to individuals or to a maintenance team. There's that step right there. And user notification would be the last step at the end. So that would be part of this right here. Establishing priorities. In many companies, systems review committees separates maintenance requests from new system development requests. Some IT managers believe that evaluating all projects together leads to the best possible decisions. The object is to have a procedure that balances new development and necessary maintenance work. Configuration management. As an enterprise-wide information systems grow more complex, configuration management becomes critical. It also helps organize and handle documentations. There's going to be different items associated with maintenance management known as maintenance releases, which you can think of as service packs in Windows or patches in Linux. Patches also exist in different database systems. All kinds of CRMs and ERP systems release either patches or service packs. And it's a numbering pattern that distinguishes from different releases. So it might be, for example, at Albertus, if it's a patch having to do with human resources, the patch number might start with HR and then a number. Or if it has to do with accounts receivable, it might be an AR and then a number associated with it, and the type of screen or patch. So there's going to be some kind of a numbering scheme or sequence that gets followed. It reduces the documentation burden and makes service packs easier to understand what they are and easier to look up as well. There's going to be version control. You're going to have archived versions, and the version control and that needs to be set up within the program and the code itself, as well as be part of the system documentation, so you have a history of what changes were done and when they were done. You're going to have to deal with baselines. Systems analysts use baselines as yardsticks to document features and performance. There's a functional baseline, an allocated baseline, and a product baseline. Fault management is part of system performance management. Here you can see below we have the resource manager, which is part of the task manager in Windows. The more complex the system, the more difficult it can be to analyze symptoms and isolate the cause. The best strategy is to prevent problems by monitoring the system performance and workload. And like you said, you can see this in Windows. I'm sure most of you know this, but if you right-click in the taskbar and bring up the task manager, it's coming up here on my screen out of view here, so bear with me for 1 second. I'll drag it in. So it's going to come in right there. You know, you can click on more details and you can see the performance just like they're looking at there. You can see the resource monitor if you click on it, and now you have a very similar view as to what they're seeing there. That's not going to be part of this class. I just wanted to demonstrate. Performance and workload measurement. We've got benchmark testing, metrics, response time, and that includes bandwidth and throughput. And I barely look at anything in kilobits per second. It's barely ever do I look at things in megabits per second anymore either. It's really gigabits per second at this point. Like I said, this book has a published date of 2014. You always want to do some kind of benchmark testing, and you always want to test the system to see that it's up and running. So here's some examples. I'm not going to go through this entire slide, but I'll leave it open for a second regarding performance metrics. That includes arrivals and the busy time, or the time that a resource is unavailable. That's a critical metric right there. Whoops, didn't mean to do that to it, but I'll leave it like that for right now. Completions are the number of arrivals that are processed, the size of the queue, The service time, the think time, that's the time it takes an application user to issue another request. Utilization and wait time. So you need to consider these metrics for the user experience as well as basic system functionality. Let's talk about performance and workload measurement. Turnaround time. The IT department often measures response time, bandwidth, and throughput, and turnaround time to evaluate system performance both before and after the changes of the system or business information requirement. Management uses current performance and workload data as input for the capacity planning process. Let's now discuss, as part of system performance management, capacity planning. You need to conduct a what-if analysis. What if Albertus' student size increased? The database would increase more than anticipated, which did happen, by the way. Need detailed information. You need an accurate forecast of future business activities. You need to develop contingency plans based on input from users and management. So if you have a heads up on what's upcoming, you'll have a better ability to plan to handle it. System maintenance tools. Many case tools include system evaluation and maintenance features. In addition to case tools, you can also use spreadsheets and presentation software to calculate trends, perform what-if analysis, and create attractive charts, graphs to display the charts and the results to management. I myself have always used Excel. I find it to be extremely robust and detailed. Microsoft Project is also a very useful tool, although I haven't used a version of that since Microsoft Project 2010, but I can't see it having changed a lot in what it does, I should say. Now we'll look at the CIA triangle. So that's not the Central Intelligence Agency, that's confidentiality, availability, and integrity. So all of these aspects must exist to have security. I've heard of data breaches where you have an end user who blabs to the press about something he saw in the system or what have you, and quite frankly that's just as bad as being hacked. So these are the concepts that we need to keep in mind as well. And security is a vital part of every computer system and every computer, I should say. Now let's look at risk management, risk assessment, and risk control. So risk management is the understanding that absolute security is not realistic. So you do need to take care of risk identification, where you list and clarify your business assets and what is at risk. And don't ever forget that data is an asset and information is an asset. And here at Albertus, that's one of our bigger assets. And we understand here that absolute security is not 100% realistic. We're not reading all of the security bulletins. We're patching Microsoft very effectively and very efficiently. We understand the concepts of the zero-day vulnerabilities and what have you, which make absolute security almost an impossibility. So we will go into that at some other time, but that's an important concept. Risk assessment is the risk of an attack multiplied by the likelihood of a vulnerability being exploited. So again, we understand that vulnerabilities exist that might not have been brought to the vendor or to our attention. So risk control involves the avoidance, mitigation, transference, and acceptance of certain levels of risk. So attacker profiles an attack. An attacker might be launched by a disgruntled employee or a hacker who is 10,000 miles away. So what they're saying here is an attacker could be anybody. Attackers break into a system to cause damage, steal information, gain recognition, or really in recent years, political issues have played a big part in these attacks. And sometimes hackers consider themselves to be gray hats, where they used to be all considered the black hats or the bad guys. Not necessarily the case anymore. So here are some different examples of some threat categories. There's extortion. That's when a hacker steals or trades secrets or threatens to release them if not paid. There's hardware or software failures. This happens in my work very, very frequently. Human error, natural disasters, a service failure. I remember working at Aleutian. They had the California wildfires, and it took down their network. So everything inside the network was working just fine. However, when students were trying to register for classes through the web, they weren't getting through because the network to the school itself was down. So there's all kinds of issues. There's trespass, espionage, vandalism, physical theft. I've seen that here at Alberta. Somebody ran off with some laptops at one point. Luckily there was nothing on them. You've got software attacks, service failures, natural disasters. I've covered that one. So all different kinds of threat categories to consider. Now there's the different types of hackers that we can also go through here. So I'm going to let you take a minute to look at this yourself. I've mentioned the activist hackers or the gray hats. I've mentioned the cyber terrorists, the employee there. So you hear of people such as Edward Snowden and what have you. He could be viewed as a cyber terrorist. He could be viewed a lot of different ways, but that's one of them. An employee, disgruntled employees. As a system administrator, I know that when somebody gets terminated, I get them out of the system as quickly as possible. There's no chances being taken there. And there's hacktivists and hackers. Script kiddies are interesting. These are people who don't necessarily know a whole lot about the computers, but they can take readily available junk scripts that can do damage to a system. And then there's a spy, and that could be a non-employee who breaks in to steal information and sell it. These are the different types of attacks and the different methods that are done. And don't laugh at some of these, like dumpster diving. That's a real thing. Password cracking is a real thing as well. And don't think that social media is not a real thing either. People definitely exploit social media. Phishing attacks. You hear about false DNS information that steers attackers to a website. This is really common at Starbucks, for example. You see people connecting to fake networks that say Starbucks domain or something, get a really strong signal. It could be the person sitting at the table next to you just using their phone, creating a hotspot. They set up their own DNS, and maybe something like Google, which is a really, really easy site to open up. So let's go to Google real quick. So actually this is a hard day for Google because it's got a special logo, but even this would be extremely easy to duplicate first. Alright, let's talk about the security levels. So throughout this entire class, I'll see a slide similar to this one where I know they're going to break down the different levels on other slides, yet I talk about it all on the main slide. So I'm going to try and not do that this time. So I'm going to go through the bullet points. So with security level, you must consider 6 separate but interrelated levels. So now I'll talk about physical security. It's the first level of security. It concerns the physical environment. That's the physical access to the computer, and it represents an entry point to the system, and it must be controlled and protected. At my day job, we have a data center in Brantford where the physical environment is absolutely ideal for a set of network servers that are commercial grade. It's air conditioned, it's well lit, it's got all kinds of access. It's also got all kinds of security. Continuing on with physical security, there could be an operations center security. That's access, getting badge access. Our Chicago data center has got extremely strong access. You actually have to get fingerprinted. You have to consider servers and desktop computers. People who don't lock their desktops, they can leave systems open all day long, so you need to consider that with physical security. Laptops, they can carry data in and out with them all day long, and I know that working at Yale, you used to have to do a scan of your laptops to see if there was any PII on it and see what you could keep or get rid of. As far as network security, encrypting network traffic, that's essential. So that's SSL encryption or SSH encryption for any kind of traffic that you're sending internally or externally. Your wireless networks need to be set up using the highest wireless standard, and that's always changing, so that's something to keep up with. Private networks and uses of VPNs are also important to consider with network security. So here, I got ahead of myself once again. Virtual private networks or VPNs. You have ports and services that contribute to network security. Firewalls will lock down any IP or port that is considered unacceptable. You've got network intrusion detection software, which can see if there's an anomaly that is considered to be an intrusion, and it reports on it. In this example right here, it shows some unencrypted data being passed. In this case, somebody could scrape the system and get the password information very easily. That's why we don't use tools and ports such as Telnet. That's port 23. It's totally unsecured at this point. Application security involves services, application hardening, application permissions, so that's permissions that you set within the application, input validation. You want to keep up with patches and updates because that will help you resolve vulnerabilities as well as system function issues. And then there's software logs where you can see particularly when a user's accessed the system, and you can perform audits. You can always find anomalies in log files. File security, important files should be password encrypted. You can use multi-factor encryption. Permissions need to be considered. User groups need, and that can be done in this example here. It's showing the event viewer that has to do with the logs on Windows. User security. Here in this picture we see an example of an RSC token ID. You can get these nowadays on your smartphones. Like I said, this book is a couple years old. I remember having one of these. It's a way to access a network, and it gives you an additional level of security. I think that's an interesting picture there. So with user security, you have to consider privilege escalation attacks, identity management, password protection, social engineering. Social engineering is researching Facebook and what have you. User resistance, and new technologies. Procedural security, also known as operational security. That's what I was talking about with desktops, making sure users log out at the end of the day. You have to prevent from dumpster diving attacks, because that's exactly what it sounds like. It's dumpster diving, so you need to use paper shredders when applicable. And information should be shared on a need-to-know concept. Now let's discuss backup policies. Backup media. This includes tape, hard drives, optical and online storage, a rotation schedule, and cloud-based storage. Nowadays, cloud-based storage is becoming much more common. Backup types. There's a full backup where everything is backed up in its entirety. There's the differential backup where just the differences, like for example at Albertus, if no, let's say, clearinghouse information was updated during the day, that file wouldn't be updated, just files that have had changes to them. There's incremental backups, which do backups of changes on a given time basis. There's continuous backups, which are occurring all the time, and the backups are constantly being run. So there's different retention periods that can be up to a month, it can be years and years. For something like Albertus, I think the retention period, it's best to maybe go back a year in case you need to look something up. Here at Albertus, I know that they do backups at certain points in time. So they might take 25 to 50 backups in a given year, and they keep those on hold. But they don't do it every single day because it would just create such a huge library. But that really kind of depends on the institution itself, how long that the records need to be kept, but they always need to be retrievable. And with colleges, the big reason for lengthier retention period really involves financial aid, because financial aid rules are changing all the time, and a lot of times you need to reference how things were when you're making calculations and reports for future needs based on past information. So here's kind of what we've gone through here with the full, the differential, the incremental, and the continuous, which I've done it again. I've talked about it in a previous slide. So I'm just going to let you take a look at this for a second, and I'm going to stop right here. Okay, go ahead and pause if you need to. So business continuity plans are very important to consider. I've actually only executed a business continuity plan once, and it was very, very precautionary. Let's say that was during 9/11. I was working in Detroit. There was no risk, but we executed the plan and created a hot site that was away from downtown, that was in one of the suburbs. And there were some flaws with our plan, but it went pretty well. So that's the one time that I've executed a business continuity plan. And data replication is an important piece of that, because you need a site that can be bought up with valid and relevant data. So replication of data has to be an important consideration. In my job, I've talked about our data center in Brantford and our data center in Chicago. That is entirely for business continuity purposes. The Chicago site that we use is actually more modern and up to date. We have more of our stuff here in Brantford just because it's more local to us. It seems easier. It's also more historical. But we could cut over immediately if we had any kind of issues. And business continuity is an important consideration. And it's also important to consider how long is it okay for our system to be down. So sometimes it's okay for a little while, most likely not. So now let's briefly go over system obsolescence. The system's maintenance history indicates that an adaptive and corrective maintenances are increasing steadily. So the older a system gets, the harder it is to keep it working with newer technologies. For example, to try and run a DOS application in a Windows environment, it's not advantageous. I've seen issues getting printers to work, getting print drivers to work. It's just very dated in its functionality. Operational costs or execution times are increasing rapidly, or routine perfective maintenance does not reverse or slow the trend. So sometimes the software just gets too old and it gets too hard to manage. And sometimes, if you have competitors and they're using better software than you, it gives them a competitive advantage. So it's got to do with efficiency, it's got to do with difficult changes, it's got to do with competitive advantage, and user requests and user happiness with the system is an important consideration as well. So once you start seeing signs, that's an indication of system obsolescence. So for these next couple slides here, I've written down open discussion in regards to the future challenges and opportunities. I wanted to open this discussion because this textbook again is from 2014, and some of the slides, which you can actually go back and look at, those slides are available. Some of that stuff I would call current challenges and opportunities rather than future. So I'm going to leave that open. If you wanted to discuss anything with that, please feel free to send a note to me. And if it's something you'd like the class to hear about, I'd be more than happy to share it. But I kind of left this out for now, and we'll go on to the chapter summary. Thanks a lot, everybody. I'm sure it's been a great class. This is pre-recorded, but the next couple weeks are going to be a lot of fun. We're going to do some mock work, and we're going to cover the first few stages of the systems development life cycle. Thank you.